Hello everyone, I hope you all are doing great. In today's session, I am going to discuss about the resonance, which I put in the introductory chemistry playlist. First of all, the question coming to my mind is that why we are going to study this new concept in order to understand chemistry in a better sense. Firstly, we have come this concept in our mind when we consider these kind of examples like as carbonate ion or the sulfate ion. When we study these structures with the help of spectroscopy, that is beyond our discussion today. So in this during that structure we are able to find that there is a presence of two multiple bonds in that structure. Firstly, let's look at the carbonate ion. In carbonate ion, we clearly depict that there are two kinds of bond, carbon and oxygen double bond and carbon and oxygen single bond. And the obvious question come into our mind that whenever we put these structures under a microscope, we are able to find out the two kinds of bond length present in that structure. But due to our astonishment of discussion today, when we perform this scenario under spectroscopy, we are able to find out that there is a presence of only one kind of bond length which lies between single and a double bond. So this means that we are able to conclude that there are several structures whose presence of multiple bonds, like as in sulfate ion, we can directly see that there is sulfur oxygen double bond as well as sulfur oxygen single bond is also present. But still, when we do any kind of spectroscopy on these kind of molecules, we are able to find out that there is only a single bond length present in these molecules. So this kind of question arising give they conclude that we have to give understand this new concept. What is the concept basically? This concept involves the describes the delocalization of electrons within the molecules. Like as we have to just deal the delocalization of electrons rather than we are not able to focus about how this molecule come into the structure or Lewis structure. We do not consider this kind of discussion in today's video, but we have to just mention the delocalization of electron within that molecule we are considering as a reference. Second is that in this structure it involves the constructing multiple Lewis structure, or from that one's Lewis structure we consider as a reference we got from the Lewis structures. We do not and give any comment on that Lewis structure, how we get that. No. So when we combined it represent the full electronic structure of the molecule. Right. Resonating structures are used when a single Lewis structure cannot fully describe the bonding. Another reason behind it study this resonance that stinks sometimes whenever we perform any kind of experiment, certain kind of structures are not able to answer all our queries in our mind. So I think resonance will be helps us to decode that kind of questions. The third point is that the combination of possible resonance structures is somewhat lead us to give one single structure that we call as a resonance hybrid. That single structure which answer our most of the questions which are comes into our mind. So that single structure is called resonance hybrid. Another is that rules before deciding any kind of resonating structures. Firstly, we have to consider that the resonance structure we have been deciding before making any kind of resonance hybrid, we have to be assured that all the resonating structures we are discussing for that particular molecules have same number of electrons. So we are not able to add or detect subtract any kind of electrons during that process. Second is the each resonance structure should follow the some rules of writing according to the Lewis structure. If the Lewis structure has given us that CH4 is a tetrahedral molecule and has a sp3 hybridization, we have to consider that without uh, any kind of further discussion over there. So we have to consider Lewis structure as a base in order to define the resonance in a better sense. The third one is the hybridization of a structure must remain the same. Like as if we say that carbonate ion, as we consider carbonate in discussion when we answer the why, the hybridization of a carbonate ion will be same throughout the structure. How many structures we are drawing on that scenario, the hybridization will remain same for the each resonating structures. The skeleton of the structure cannot be changed. Like that if we said that the carbonate ion is arranged in sp2 hybridization, so throughout the resonating structure we are not going to change the carbonate ion skeleton. Just we have to move the electrons, because in our first definition we have mentioned that resonating theory is basically a delocalization of electrons within the molecule without any movement of bonds or a skeleton. Resonating structure must also have the same number of lone pairs. If we consider that when we draw that particular structure, we have to check that if for the first structure, suppose there are 6 lone pairs are present in that structure. So throughout the structure, whenever we do any kind of movement of electron, those 6 number will be remain same. So these are the few rules which we have to be keep in mind whenever we decide on the resonating structures. Now this is the basic example I have been considering for this discussion, because for understand the resonance in a better sense, I think this is the simplest example I have been considered. But in the resonance part 2, I have been considered some typical example in order to give some answer about the technical complexity of the resonance. Firstly, what we have to do is we have to find out the first rule, that is valence electron will be remain same throughout the structure. That means for the carbonate ion we have to calculate the valence electrons. Valence electrons are those electrons which are participate in bonding. Like as if in carbon we have considered the carbon electronic configuration is 1s2, 2s2, 2p2. So 2s2, 2p2 is considered as a valence electron for the carbon atom itself. So in this manner we calculate the valence electrons for the whole molecule. That comes out to be 24 for the carbonate ion. And now we had moved towards the second step, that is the draw of the resonating structures. Firstly, when we are not able to get our resonance hybrid, these all kind of structures are called contributing structures, because they have show some contribution towards our permanent resonance hybrid. First structure, there is some rules we are have to follow some rules, like as whenever we do any kind of movement of electrons, both arrows are in the clockwise or in the anti-clockwise direction. Never do one movement in clockwise direction and one movement in anti-clockwise direction. So we have first rule is to do whenever we move the electron, we have to move to the in the same direction. So when we use the double-headed arrow, the double-headed arrow means there is a migration or the movement of two electrons at one time. So, right? If the half-headed arrow will be show on the migration of atoms, during migration of atoms, that means only single electron will move. So in this scenario, two electrons will move at a time. That's why the arrowhead is double-headed, right? So when we move from one contributing structure towards another contributing structure, there will be a presence of a double-headed arrow. That means these both structures are interconvertible. So this is the basic rule or a terminology we have to keep in our mind before drawing any kind of resonating structure. This is the simplest one. So firstly, carbonate ion, we have to move the electrons. So in this manner, if we start doing migration, we have doing from this oxygen to multiple bond present oxygen. So in this manner, we reach to another structure. In this manner, it leads to third structure. Sometimes students are very much confused while writing the movement of electrons. So if you are feeling that you are not able to justify the movement of electrons, rather than deducting the marks or losing the marks, so I think it's better to avoid the movement arrow. So second methodology is also a perfect way to show the resonating structures. So these are basically a resonating structures, or sometimes they are mentioned as contributing structures as well. And the last final structure who is bear down the properties of the both all these contributing structures is called the resonance hybrid. So this is the one structure which we get from all these contributing structures, and this structure due to all this reason why we get the single bond length. This is the basic reason behind that. There is a phenomena of resonance behind it, so that we are able to get the single bond length structure for the carbonatite. That's all from this session. Thank you so much.